Students, this is the preview video for similarity and proportions. Similarity and proportions. In this lesson, we're going to accomplish these 4 things in the next 30 minutes. We're going to explain the difference between the concepts of ratio versus proportion. Number 2, we're going to actually solve proportions, where the key to multiplying is not multiplying, but factoring. We're going to understand the impact that differing units have on ratios. We're going to define the concept of similarity and use it to set up and solve proportions. So, number 1. We're going to explain the difference between the concept of ratio versus proportion. They are related, but they're not interchangeable. So a ratio is a comparison of 2 numbers by division. By division. When you're working with units, you must get in the same unit before you make a ratio. We'll be talking about these 2 pages from your reference booklet in just a moment. I recommend you have them handy. These 2 pages. Styles of ratios that you're with. One word. So one would be the word 3 to 4. Like 3 cups of flour to 4 cups of water to make plaster of Paris. 3 to 4 using a colon would be the same ratio. Over 4 as a fraction is a ratio. And then you change it to a decimal. 3/4 of a dollar is 75 cents. All of those are ratios, different styles. A proportion is an equation of ratios. A proportion is an equation of ratios. For example, if I had the proportion 4/8, the ratio, I could reduce that to 1/2. So 4/8 equals 1/2. This yellow is a ratio. This blue is a proportion. And there's a property with proportions. Let's order these numbers from least to greatest. So the least is 1, then 2, then 4, then 8. The 2 numbers in the beginning are called the extremes. I like you to connect them. Those are the extremes. Let's go ahead and multiply. These ones in the middle are called the means. The extremes and the means. Let's multiply those. If you look carefully, you will see that the multiplication of the extremes is the same as the multiplication of the means. You guys know this as cross multiplying. Technical name is the product of the extremes is the same as the product of the means. And that's true of all proportions. Number 2. We're going to accurately solve proportions where the key to multiplying is not multiplying, but factoring. The key to multiplying is not multiplying, but factoring. So right here, let's go ahead. We're going to multiply the means and the extremes, but watch very carefully. Do not be grabbing for your calculator right now. We're just going to write these numbers down. Now I'm going to show you a trick to not use a calculator. Why? Because you're intelligent young people and your brain is more powerful than you think it is. The key to multiplying is not multiplying. It's factoring. So rather than grabbing your calculator for multiplying 33 times 35, watch what we do here. We're going to factor. So we're going to divide out the 15. Follow along, please. Now we're going to reduce where we can reduce. I like the circle, the 35 and the 15. 5 goes into both of those. 5 goes in there 7 times. 5 goes in there 3 times. Now I'd like you to box the 3 and the 33. 3 goes into 33 11 times. 7 times 11, K equals 77. Aren't you smart? Looky there. You can do multiplying without multiplying, but by factoring. Let's do another example together. So we have here 10 times 14. We're going to get P by itself. We're going to divide by 2. Doesn't matter whether you take the 2 into the 14 or 2 into 10. It doesn't matter. I'm going to take the 2 into the 14, which is 7. The key to multiplying is not multiplying. It's factoring. Now, it's super important that you'll also learn how to do proportions using words. Ready? We're going to finger track and read this out. Put your finger right there and read aloud with me. 2 supplementary angles have a ratio of 3 to 2. Find the measure of the angles. Now, let's go back and underline the key words. We have supplementary angles, ratios of 3 to 2. Our goal is to find the measure of the angles. Okay, now keep in mind what a ratio is. It's a reduction of, if I had 30 of something over 40, I divide both sides by 10 and I end up with 3 to 4. So my ratio would be 3 to 4. So keep in mind, when you see a ratio, technically it's a reduction of something else. So a 3 to 4 ratio is 3 of something and technically 4 of the same something. A ratio is a reduction of something else. So in this scenario, supplementary, you should know that means 1 You just draw a linear pair. And my ratio is 3 to 2, so that's 3 of something and 2 of something. So to solve, we know supplementary by definition means 180. Go ahead and trace with me that means 3x, trace, finger on paper, plus 2x equals 180. Go ahead and solve. Now you're not done. You just figured out what the something was. So now we come back here. 2 of something is 2 times 36. $72, and you simply take 72. So to recap, a ratio is a reduction of a comparison of somethings. Okay, we're halfway there. This page, I'd like you to try on your own and then restart the video when you're done. Pause. Welcome back. Hopefully you actually did this without a calculator. If you use calculator, you're cheating and you're not following my instructions. So we should have cross multiplied. Key to multiplying is not multiplying, so instead I just do this. 10 goes in there 3 times. I have a 3 and a 15. 3 goes in there 5 times, so x equals 5. If you multiply 13 and 9, you wasted your time. Down here, 2 complementary. This time, they add up to 90. And this is 4 of something and 1 of something. Sorry, with close angles. That was 5x equals 90. You should have gotten one angle equaling 18 degrees. Therefore, the other angle is 72. Halfway there. Now, we're going to understand that differing units have on ratios. Different units have on ratios. Remember, the definition of a ratio is a comparison of 2 numbers. Here's an additional clarification. In the same unit by division. In the same unit by division. Put your finger here. Let's read this out loud. Have this page handy where you can see it. Once again, that is your units page. Right there. Have this page where you can see it, please. It says, fish needs 3 feet of Velcro for every 2 yards of fabric purchased to make a table banner. What is the ratio of the Velcro needed compared to the fabric? So we're going to here, we're making a ratio of the amount of Velcro, so just write the word Velcro, to fabric. Now, this is where mistakes are made. You read it, and the only thing your eyeball picks up are these numbers, and then you do something like this. Oh, the ratio of Velcro to fabric is 3 to 2, because there's a 3 there, and you see the word Velcro, and there's a 2 there, and you see the word fabric. Wrong. Absolutely wrong. And the reason is it's 3 feet of Velcro to 2 yards of fabric. To make a ratio, you must be in the same unit. So first off, it's 3 feet to 2 yards. Always convert the larger unit into the smaller. So we know, if you look here, and we're talking about length, and we're in the first dimension, we know that right here, in the first dimension, 1 yard is 3 feet in the first dimension. So that means 2 yards with 3 feet each yard is going to be now 3 feet of Velcro to every 6 feet of fabric. So my actual ratio of Velcro to fabric is not 3 to 2. It is 1 to 2. Ratios must be in the same unit. Let's get another recipe here. It says, an industrial size recipe to make 300 chocolate chip cookies calls for 800 grams of sugar for every 2.5 kilograms of flour. So here's your 2 elements, sugar to flour. Now, once again, the immediate knee-jerk reaction is to go like this, 800 to 2.5, make that your ratio. And that would be incorrect. Because it's 800 grams. To 2.5 kilos. Grams of flour. So step 1 is to get in the same unit, and it's always easier to go from the larger to the smaller unit. So the question you have to ask yourself is, how many grams in a kilogram? Students, let me make this super clear. I expect you to have the unit conversions on these pages memorized. So taking a look here, how many grams are in a kilogram? And if you look right here, the word kilo means 1,000. So there are 1,000 grams in a kilogram. So right here, if I have 800 grams of sugar, then this is going to be 2.5, that's 2,500 500 grams of flour. Now to make a ratio, you have to reduce. So we're going to reduce 800 to 2,500. And two zeros. You look at this last little bit, see if there's any way you can reduce 8 and 25, and you can't. So the actual ratios of sugar to flour is an 8 to 25 ratio. This page you're going to do on your own. Restart the video when you are finished. Take a look and see what you did here. Okay, we have 44 centimeters to 2 meters. Hopefully this is not 44 to 2, and then you reduce and you end up with 22 to 1. That is not correct, because that's centimeters. You need to get the meters into centimeters. There's 100 centimeters in a meter. So this is going to be 44 cm to 200 cm. Now you reduce 44 and 200. I'm going to start dividing both by 2. And I get 22 over 100. I can still divide by 2 again. I get 11 over 50. So your final ratio should be 11 to 50. That is your final ratio there. This one, Harley Davidson, each wheel travels 82 inches to a mile. So we have here 82 inches for every 1 mile. Hopefully you caught the fact that this was a double conversion. Step 1, you had to get the mile into feet. Again, that is right here. There's 5,280 feet per mile. So 1 mile is 5,280 feet, but you have to go 1 step farther to get it into inches. 12 inches per foot. Yes, for something like this, you may use a calculator. So 5,280 feet times 12 is 63,360. So for every 82 inches of tire rolls, you get 63,360 inches. So I'm asking, what is the ratio? In other words, how many times does the wheel turn in a mile? Now that you have it in the same unit, you go ahead and you divide. And you get approximately 772.7 revolutions. So your ratio for mile for revolutions, excuse me, it's the other way around. For revolutions per mile, ratio of how many revolutions per mile is going to be 772.7 revolutions for every 1 mile. All right, the last thing we're going to do is we're going to define the concept of similarity, which is related to proportions. We're going to define similarity and use to set up and solve proportions. Here is a simple definition of similarity, kind of like a layman's term. Items which are similar have the same shape but a different size. Items which are similar have the same shape but a different size. I'd like you to just underline these words. Similar, same shape, different size. Say that with me again. Similar, same shape, different size. The symbol for similarity is that. Looks like a Spanish tilde. So we see here the oil life shirts. We have a small, medium, and large shirt. They are the same shape of shirt, just different size. We would say these shirts are similar. Now that was a simple definition of similarity. Same shape, different size. Same shape, different size. Bear with me. Same shape, different size. And there's a technical geometric name of similarity, and that has the acronym STAIR. Go ahead and fill that out. Similar shapes have congruent angles, side ratios equal. Similar shapes have congruent angles, sides ratio equals. Let's say it and write the acronym. Similar shapes have congruent angles, side ratios which are equal. Similar shapes have congruent angles, ratios equal. Congruent angles, ratios equal. So here's an example of similar shapes. Step one, we check to see if you have corresponding congruent angles. And look here, we have all corresponding congruent angles. Now check your side ratios. Underline the short side to the short side, and you review. Now trace long side to long side. Reduce. Notice the side ratios are equal. 1 to 6, 1 to 6. Therefore, we would say these shapes, because they have congruent angles, ratios equal, are similar. Last new vocabulary, then we're going to do some really easy math here. The concept of scale factor only applies when shapes are similar. So put a little similarity sign in front of that. Scale factor is the ratio of the sides simplified. The ratio of the sides simplified. In other words, it's one side compared to the other side of a similar shape. One side, two sides. Let me give you an example. So find the scale factor of the similar shapes. This only works if shapes are similar to begin with. So ready? Ratio of the sides simplified. So step one, I'm going to find the short side and go to the short side. Now, simplify. 5 goes in there, 2. 5 goes in there, 3. Let's check to see if we're correct. Now we're going to go ahead and check the medium size. Medium to medium. Notice I'm matching the side lengths here. 7 goes in there twice. 7 goes in there 3 times. Notice the ratio is equal. So we would say the scale factor from left to right is going to be, of those, 2 to 3. Of those shapes, left to right is 2 to 3. Okay, so here we're going to determine if the shapes are similar to begin with using scale, congruent angles, ratios equal. Let's do this first one together. Ready? Notice the parallel lines here. Very important to notice. Leave a double parallel. Leave a double parallel. Now that's matching. That means those are consecutive interior angles known as same side interior, which means they add up to 180. So if this is 80, this is 100. And this is 100, this is 80. So now we check corresponding angles. Corresponding angles. And notice the fatter angle here is 100, fatter angle there is 100. Smaller angle is 80, smaller angle is 80. So there's our first check, congruent angles. Now you check side ratios. 7, 14. It's a 1 to 2 ratio. You check all the way around. 1 to 2. And of course, you see it's a 1 to 2 all the way around. So we would say these shapes are similar. Yes, they're similar. Let's come over here and check the ones on the right. First, you want to check for congruent angles. See it? So we see here, those are matching angles. So good so far. And then these double sweeps mean these match these double sweeps. Okay, we're good so far. Now, we're going to check short to short, long to long, and check our ratios. So short side 12, short side 16. Reduce. 4 goes in there 3 times. 4 goes in there 4 times. Short to short. Now, let's check long to long. Reduce. 8 goes in there twice. 8 goes in there 3 times. Looky there. Even though you have congruent angles, your ratios are not equal. So these shapes are not similar. Now, if we do have similar shapes, that means we have ratios which are equal. Then you can learn proportion side. We use proportions to solve for unknown length. Remember, proportions are equations of ratios. So guess what, folks? I got good news for you. If you know how to comfortably cross multiply, congratulations. That is about 90% of what you're doing for this entire unit. Let me give you an example. You ready? These shapes are similar. Similarity means congruent angles, ratios equal. So immediately I know I have equal ratios, which means a proportion. And the only thing you have to do is match and mirror. Match and mirror. Say those two words with me. Match and mirror. Ready? Let me show you what I mean. We're going to go short side to short side. Okay, so short side 24 to short side 4. And I'm going to go left to right. Match the sides, mirror the direction. Match and mirror. So match the sides, mirror the direction. Then I'm going to go diagonal to diagonal. Diagonal to diagonal. Match and mirror. I match the sides, I mirror the direction. Okay, now, so that's a complete proportion. We know it's a true proportion because if you reduce, 4 goes in there 6 times and 6 goes in there 6 times. So I know my ratio left to right is 6 to 1. I'm just confirming. So now I can use that to get my unknown side. So here, match 42. Near the direction, unknown, boom. Cross multiply, solve. X equals 7. Match and mirror, match and mirror. As long as you match and mirror, you're in good shape. I'll do one more. So find the variable and the side length, knowing the shapes are similar. And watch very carefully. A little bit of trick there. Similar. It says scalar factor from A to B. Watch. Notice the direction going from A to B. So draw an arrow from A to B, and my ratio is going to be 3 to 5. Do you notice the direction there? So I'm going to make a ratio 3 to 5 from A to B. In fact, I'm going to make a little notation, A to B. Match and mirror from A to B. So to solve, I'm going to go from A to B again, which is 2x plus 10 over the matching 40. Cross multiply. 3 times 40, 5, 2x plus 10. Notice the key to multiplying is not multiplying. Instead of distributing, you can if you want. That's a long way around. So you're shortcut. I'm going to divide both sides by 5. That goes in 8 times. And 24 equals 2x plus 10. Let's take it from there. Now, what's really nice is you can test every single one of these. So, 2 times 7 is 14, plus 10 is 24. Now, we check our ratios. Remember, we're going from left to right, right to left. So, I have 24 to 40. Let's check to see if that holds true. right? 24, 40. We reduce. 8 goes in there 3 times. 8 goes in there 5 times. Ta-da! It works. So now, knowing what you've learned about scale, I'd like you to try these 2 pages on your own in pencil. Restart the video when you're done to check your work. All right, first one, let's check. Here we have congruent angles. Let's check ratios if they're equal. I'm going to go short to short. Okay, 6 goes in there 5 times, 6 goes in there 6 times. That's a 5 to 6 ratio. Let's check this one. 40 to 48. All right, 8 goes into 45 times. 8 goes into 48 6 times. This first one is yes, it is similar. You come over here, you check your ratios. Got 120. We do have congruent angles. Let's check our sides. I'm going to go long side 30 to long side 36. Okay, and we check. 6 goes in there 5 times. 6 goes in there 6 times. Now I'm going to go short side 25 to short side 30. 5 goes in there 5 times. 5 goes in there 6 times. So I have a 5 to 6 ratio. So again, yes, it is similar. Here, given the shapes are similar, find the missing side length. So match and mirror. Match and mirror. I'm going to go short side to the short side. 24 to 28 equals longer side to longer side. Right. Notice that cross multiply. Notice the key to multiplying is not multiplying, it's factoring. So let's see, I know that 6 goes into 24 4 times, and 6 goes into 35 times. 4 goes into 28 7 times. 5 times 7, we should have gotten 35. Matching there, matching there. So I'm going to go here, short to short, 15 to 20, long to long, 30 to unknown. Cross multiply. It goes to 30 twice. My answer here, 2 times 20 is 40. Notice, watch out, the variables A2, B3. We're going left to right this time, 2, 3. So A2, 3, that's A2, B equals, and then you go x plus 3 over 21. Cross multiply. And divide both sides by 3 rather than distribute. I think x equals 11. Let's see if that's true. I'm going to put an 11 here. I get a 14. So I do 14, 21. 7 goes in twice. 7 goes 3 times. There. 3, B, 7. Notice the direction we're going. There's now right to left. So 3 over 7. A to B. This time it's right to left. Equals A, 36 to B, 3x plus 27. Let's multiply. Key to multiplying is not multiplying. Factor. So instead of just sitting in 3, I'm dividing. I can take that in there 12 times. I can do my third grade math. So 7 times 12, 84. So I'm going to be doing 57 equals 3x, 5 by 3. I get 19, 5x equals 19. Let's check to see if that is going to work. You just plug in your 19 there, and then you get a 3 to 7 ratio. Make sure you take the time to verbally rehearse what you've learned today. You're going to be turning this in for extra credit, realizing if you turn it in, take the time to summarize what you have learned.